Let us see an example on shear reinforcement design. In my last video, I discussed the theory of shear reinforcement design in beam. So here we will see an example. So what is this example? So there is a beam here. It is 18 feet long. It has live load 4 kip per feet, dead load 2 kip per feet. And the section based on the flexural design, we found that we need 4 number 9 bar. The width is 12 inch and the height is 30 inch, and the distance from compression phase to the reinforcement is 27 inch. And my material properties, 4000 psi concrete, 60,000 psi is steel, and it is normal weight concrete. That means the concrete we used here is normal weight, and it includes self weight. That means whatever the dead load is given, it includes the self weight. So this is the problem. What we will do, we will design the shear reinforcement. What is shear reinforcement? Shear reinforcement means this stirrup. So we will design this stirrup and their spacing. Say if this is my beam, what will be the spacing? What will be the spacing? So we have to design the spacing, mainly the spacing and the size. Size we will assume, then we will calculate the spacing. Okay. So in my last video, I showed you or I told you the steps to do it. So what is step number 1? Step number 1, I have to find the shear force diagram. We are designing for shear reinforcement. So we need the shear force first. So to determine shear force, so step number 1, if I say I have to calculate shear force diagram. So shear force diagram, let us find our force. Our WU is 1.2 D, 1.6 L. So 1.2 D means 2, 1.6 L means 4. How much? 2.4, 6.4. 2.4, 6.4. That means 8.8 kip per feet. So that is the uniformly distributed factored load. Okay, then what is my Vmax? Vmax for this kind of beam is WL by 2. So 8.8 times L is 18 feet over 2. If I use my calculator, 8.8 times, so 79.2 kip. That means 79,200 pounds. So that is my maximum shear force. Okay, so I will delete this portion to make some room because I need this room. So hopefully you understood how I found the maximum shear force. It is from your statics class, strength of material class, or structural analysis class. You saw this. Okay, then diagram. So middle is this here. So this is here 79,200. It is my shear force in pound. Okay, I'm making it short. Now, what is our what is our design shear force? This is not the design shear force. Design shear force will be at D distance. So at D distance, say here to here is 27 inch. So here, what is this value? We will have to calculate this. This is our design shear force. How to calculate this? Okay. So our value was 79,200 pound, and it is decreasing by, can you remember what was our W? Our WU was 8.8 kip per feet. That means this curve is going down by 8.8 to 8.8 kip per feet. So minus 8.8 say this pound per feet. So it is decreasing this way. After traveling 27 inch, After traveling 27 is, that means this foot, what is my value? Yes. So my initial value was 79 2000. It is decreasing 8,800 pound per feet. And after going 27 over 12 feet, what is my value? Okay. So if I use the calculator, 79 200 27 divided by 12, I got 59 400 pound. So 59 400 pound. So this is the shear force here. That is my design shear force. So we got one. Then we will calculate what is the maximum amount of shear force my concrete can take. What is that? So PVC. PVC is 2 lambda phi A prime C B D. So 2 lambda means 1. Lambda is lambda 1 is for normal weight concrete. If it is lightweight, then we would use the factor for lightweight concrete, that is 0.85. But our concrete is normal, so 1. What is our phi? Phi is 0.75. A prime C is 4000. B is 12. D is 27. So how much my concrete can take? So if I use the calculator, 2 times F prime C 4000 75, I got that my concrete can take 30,737. So my concrete can take this amount of shear force. What is my shear force? 59,000. That means I need to provide the shear reinforcement. Okay, so now we need to locate this shear force somewhere here. We need to locate this shear force. How we will locate it? Same concept we did here. So at the beginning my shear force was 79 200. Then it is decreasing this pound per feet. So 8800 pound per feet. Now where I got it? It is my uniformly distributed factor load. Now say after we do not know the distance, say we are assuming this distance is x. So this distance is x. So after this traveling x feet, my value is 30,737 pound. Yeah, hopefully you understood this equation. Initially my value was 79,200 pound, and then it is decreasing 8,800 pound per feet. Where I got it? This is my WU. And then after traveling x feet, I do not know the value of x. My value is 30,737. Then we can solve it to find the x. Okay, so if I skip a line here, so 79 200 minus 737 is divided by 8800. I got my x, which is 5.5 feet. If I convert it into inches, it is 66 inches. Okay, so this portion is 66 inches. Okay, now so we got our this reason. Now what is here to here equal to no problem. So 66 minus 27. So this portion is actually 39 inches. It is very important to calculate this distance accurately. So this value is phi BC, which is 3737. Okay, I am not writing the unit. I wrote here to make it simple. Okay. Okay, then we need to, this is the amount of shear force my concrete can take. Now, ACI code told us that provide reinforcement up to PVC by 2. So we need to calculate that. Simple. We already did it, divided by 2. So 30,737 divided by 2. What is that value? So 30,737 divided by 2 is obviously, you know it, 15,369. Okay, now we need to locate it where it is located. We need to locate this value. Okay, same concept. Say this time I am using y. Then how I will find it? Okay, I will write here y then 15,369. That means my initial value was 79,200. It is decreasing 8,800 pound per feet. After traveling y feet, my value is this. Now what is my y? Calculate it. I am skipping one line here. 15,369 divided by 8800. So if it's 725 feet, if I multiply by 12, it becomes 87 inch. So here to here is 87 inch. Then what is here to here? 87 minus 39 minus 27. So this portion is only 21 inch. Okay, so we are progressing. So I will delete it. Hopefully you know how I got 39, how I got 21, 87, 66. It's all about like PVC over 2. Now all about calculation, normal calculation. So I will erase this portion. Okay, I will also erase this portion to make some room. Okay, then something else. And then we have to calculate the distance. So this is reason number 1, reason number 2, reason number 3, reason number 4. Reason number 1, we do not do any calculation. We do the calculation reason number 2 and copy paste here. Reason number 3, we do not need any reinforcement, but still though my code says provide reinforcement up to PVC over 2. So here we will provide the minimum amount of reinforcement or maximum amount of spacing. Reason number 4, we do not need reinforcement at all. But you can provide just to tie the main bar, that but no mandatory. That is up to you. Okay, so now to calculate the spacing, you know that we need to calculate and there's another parameter we should check, which is 4 p lambda a prime c bd, and there is another term 8 phi lambda, oh, actually not phi, only 4 and 8. We need to calculate these two values because in the spacing calculation, if you see the table that I showed in the previous video, which is a page from a reference handbook, you saw that there's a table. If your BS means that whatever the shear force taken by steel is less than this or more than this, there is separate equation. So I need this two value, and BS cannot exceed this. No way my BS can be more than this. BS means amount of shear force taken by steel. Okay, what is this value? This value will be 4,027. So I got a value which is 81,966 pound. So this portion will be double of this, 163 932 pound. Okay. Okay, now we need these two value. I'll go there, but before going there, let's come here. So we will start reason number 2. Okay, in reason number 2, what is the amount of shear force taken by my steel? That is, if you see the equation, it is PBC over 2 divided by P. I showed you this equation. So, right here, reason number 2 we are doing here. So what is the amount of shear force taken by steel is this. What is this value? This value is, again to tell you, VU is this value, not the maximum one, the value at D distance. So minus 37. I need some space, so I will erase this portion. Divided by P is 0.75. So 37 divided by 0.75. So I got this value 38 to 17 pound. Okay. So VS cannot exceed this value, never. If my VS is more than this, my section is wrong. We have to revise the section. So my value is not more than this. So at least my section is good. Number 1. So the purpose of this is done. Second thing, if this value less than this or more than this, depending on that, I have separate equation to calculate my spacing. Now this value is less than this, right? So this value is here my VS is less than this. So what is my equation? Okay, then from the table you can find the spacing equation. What is the spacing now? Spacing is required. What is the required spacing? Required spacing is this equation. If you can remember this equation, required spacing is this equation for reason number 2. What is AV? Area of shear reinforcement, area of this reinforcement. Now what is the area of this reinforcement? You have to assume a size. Now what size you will take? Number 3 or number 4? You know that if main reinforcement is number 10 or less, this should be number 3. If this reinforcement is number 10, more than number 10, that means 11, 14, 18, then this will be number 4. So we can easily take, say, number 3 bar. Number 3 bar. What is the area? Area of number 3. Area of number 3 is 0.11 inch square. Now, 1 bar here, 2 bar here. So 2 times. So my area will be 0.22 inch square. Then Fy is 60,000. D is 27 inch. Vs is 38,217 pound. Now I have no space here, so I'm not right. Okay, right here, this is PSI. If I write here, so 0.22 times 60,000 times 27,000 divided by 38,217. I got distance 39.3 inch. That means in this region, my reinforcement spacing will be 9.3 inch. Now that is the required spacing. Now what is the maximum permitted by the code? So that I can provide at least the minimum amount of reinforcement. So if I go there in that table, find the equation, I can remember that if Vs is less than this, my S max possible is D by 2 or 24 inch. So far I can remember. Let me check with book. Yes. So this is the maximum, this is D. If Vs is less than this, D by 2 or 24 is. If Vs is more than this, then D by 4 or 12 is. I am using the right equation. So what is this value? So 27 by 2 or 24 inch. That means 13.5 inch or 24 inch. That means this value is critical, control. Now, in reason number 2, I found my spacing required is 9.3 inch. My code says I can provide maximum 13 inch or 24 inch. So what is our conclusion from this? We should take the minimum spacing so that we are in conservative side. So in reason number 2, okay, or better make a table. Make a table. So reason 2. Reason 2, my answer is 9.3 inch spacing. Reason number 2, or right here spacing. 9.3 inch, we got an answer. Now, it is not the final design. Final design depends, we have something to consider. That means the spacing should be round number so that laborers can easily place it. And also we should check the distance. We will go there. So reason number 2 is done. Now whatever we got reason number 2, we'll copy paste in reason number 1. So reason number 1 is also done. Then we'll go to reason number 3. Okay. So let us go to reason number 3, or delete everything to make it clean. Now what is reason number 3? Reason number 3, we do not need to provide any reinforcement, but code says provides the minimum. For that case, what is the S required? If you see the see your book, okay, when I cannot remember the equation, it is this equation: AV, FY, 50, PW. Yes. Or yes, required is AV, FY, 0.75, BW, A prime C. So this equation, this is the required. What is the maximum possible? What is the S max possible? It is D by 2 or 24 inch. So D by 2 or 24 inch. We know that this portion is 13.5 or 24 inch. Make sure that you know when I am getting this equation. It is in your book, or whatever book you follow, it must be there. But in my previous video, I showed you one page, a summary table, which has this equation. Okay, now this equation is for reason number 3. So what is this one? Again, 0.22, 60,000, 50, 12. Uh, 0.22, 60,000 divided by 50 divided by 12. I got here 22 inch. What is the value here? Again, 0.22, 60,000, 75, 12. How much here? 0.22, 60,000, 75, 12. I got here 23 inch something. Okay, so reason number 3, I got how many distance? 22, 23, 13. So which one I will consider? 13. It is the minimum. So reason number 3, I got 13 inch. Okay, then reason number 4, we do not need to provide any reinforcement unless we need it for the time. Okay, so we got answer. So make sure that you know which equation to use. It is in your book. I will erase it. Now is our design. Now this is not our design. This is just the raw calculation. Sorry, not 13, 13.5 is. Now I will, okay. So reason number 1, reason number 2, we will provide 9.3. So 9.3 is not a round number. So better to take a round number, say 9 inch. 9 inch is a round number. You can provide more spacing. That means you cannot provide 9.5 when your required is 9.3, but you can provide less spacing, so 9. So if I provide 9 inch, you can see that my up to 66 inch, up to 66 inch, if I provide 9 inch, how many bar do I need? 66 divided by 9. 66 divided by 9, that means 7.33. 7733 bar. Okay, now what about if I provide 8 bar? Okay, now there's another discussion. At the beginning, I cannot provide at 9 inch. I have to provide at half of this. So if I make this space bigger, okay, if I make this space bigger, say here to here, this portion is 27 inch, then this portion is 39 inch, then here to here another portion that is 87 inch. What is here to here is 9 feet, half of this, and 9 feet, that means 108 inch. Okay, so okay, I have to provide in this region. If I say 9 inch, then my first reinforcement should be at half of this, 4.5 inch. So 4.5 inch, half of this, because will take force 5 inch that side, 4.5 side. But again, 4.5, I do not like this traction in here. It is okay, or you can provide even 4 inch. That is better. Okay, so for practical purpose, I am designing 4 inch. Although 4.5 inch is good, there is no problem. So I am designing at 4 inch at the beginning. Okay, then up to this point, what is my distance? 66. So 1 bar at 4 inch. Then what is my left? Left is 62 inch. Left is 62 inch. Then if I provide at 9 inch, so 62 divided by 9. That means I need 6.9 bar. So what I will do? I will provide 7 inch at the rate of 9 inch. Hopefully you understood what I did here. I am providing my first bar at 4 inch. Then I have how much left up to this? I have left up to 62 inch here. 62 inch here. I am providing 7 bar at the rate of 9 inch. Then I am covering 1 inch more. 1 inch more. I am 1 inch more. Yes, 1 inch more, because 63 inch, then 4 inch. Okay, then that is covered. Then I came somewhere here. Then how much do I left here? Here I am leaving here 87 minus 67. I have 20 inch here. 20 inch left here. Now what is my required spacing here? 13.5. I have 20 inch. Now you can feel here now. If you provide only 13 inch, you can provide only 1 bar. But it's matter of only 1 bar or 2 bar. So better to be safe, and you have 21 inch, and if you provide only 1 bar after 13 inch, then something is left here. Better to be practical, provide 2 bar at 10 inch, or even I can provide 12 inch. Then I am covering another 14 inch. That means I am going more than this. I am going more than this up to this. If you provide more, there is no problem. To round up, you can choose this configuration in reason number 3. Reason number 4, how much left? That means you are covering how much? 24 plus 37, 91 is. How much left here? Left here is 17 inch. This 17 inch you do not need any reinforcement, because 17 inch is only this 17 inch, roughly this. So you do not need to provide any reinforcement. So now what to do? You have to sketch this, or I can sketch even here. So I am sketching here. So 1 bar 4 inch, then up to this, here to here, 7 at the rate of 9 inch, then here to here, 2 at the rate of 12 inch. 1, 2, 3, 4, 5, 6, 7. Then 1, 2. Okay, done. So this is our final shear reinforcement design. Oh, I did not tell the number 3. Okay, so again, if I summarize what to do for shear reinforcement design: first, draw your shear force diagram, locate your VU, locate PBC by 2, locate PBC by 2, calculate the distance. Then go to reason number 2. Reason number 2, calculate the required spacing, then calculate the maximum spacing. Okay, keep it. Then go to reason number 3, calculate the required spacing, calculate the maximum possible. So 3 is done. 4 you do not need. 1, whatever you will get, 2 you will copy paste. Now once you get the raw data, then based on the distance and spacing, choose a round number, and you can provide more, you cannot provide less. Then once you choose a round number, you have to do this calculation. Now this portion takes time. In your exam, do not try to do it very perfectly. In real life, you can do it. Now it needs some trial and error. Go back, forth, change. Even there's not a unique solution. Different students will come up with different answer. If say somebody use here 10, is it problem wrong? Never. It's okay. If somebody says 13, is it problem? No. If somebody says 13.5, no problem. Even if somebody says here 9.2, no problem. So there are so many answers, but as long as is providing more than the required is good. Okay, then finally do not forget to show the sketch, because the field site engineer or the field labor will read your drawing. So hopefully you understood. In the next video we will solve more problem. Thank you.